And we'll make a start. Well, so ladies and gentlemen, welcome to today's event, where we'll be showcasing 2 new decision support tools for sustainable transport in low-income countries. I'm Professor John Preston from the University of Southampton, and I'll be your moderator this afternoon. Before we start, I'd like to just go through some housekeeping. For those of you joining us online, live transcription is available by clicking the CC, that's the closed caption icon at the bottom of the Zoom screen. Presentations will be shown during the webinar. To make a comment or ask a question, if you're joining online, we ask that you use the Q&A feature. This will give you the opportunity to comment on other questions, as well as answer questions through the Q&A comment feature. And hopefully if my laptop's working correctly, I'll be reading those as well. Please be aware that the chat feature can be disruptive for those using a screen reader, and we ask you to not use this feature when people are speaking. The webinar will be recorded, and following the webinar, links to any videos, summaries of the key points discussed, and any actions will be shared with all attendees. This webinar is part of the outreach activities of the High Volume Transport Applied Research Programme, HVT, as I'm sure many of you are aware of. The HVT programme is funded by UK Aid and is undertaking research into sustainable transport development in low-income countries in Africa and South Asia. So I'd like to start off our session by inviting Dr. Bernard Obika, HVT's team leader, to make the opening remarks. Bernard, the lection's yours.
Thank you, John. So it's my pleasure to welcome you all to today's event. I extend my greetings particularly to those who are online. By the close of business yesterday, we've had people register from over 35 countries across the world. So you're particularly welcome. And of course, to those of you who are here present today. As John said, my name is Bernard Obika. I am the team leader for the High Volume Transport Applied Research Programme. So we're delighted that you're able to join us to launch the update of the Road Note 31 and the new toolkit for decision-making in low and middle-income countries, particularly with regards to climate change. Have the next slide, please. Okay, so as John mentioned, the High Volume Transport Applied Research Programme is a 5-year, £18 million investment by the UK Foreign and Commonwealth and Development Office that aims to change transport and make it greener, safer, more accessible and inclusive. The program is delivered through a program management unit run by DT Global, an international consultancy that concentrates on development globally. So just to give you an example in terms of what we do, the current priority research areas for the program include climate change mitigation and adaptation, affordable and efficient transport systems. So for example, we're working on transit-oriented development and improving the informal transport system, which accounts for over 70% of the movement in many low-income country cities. We're also looking at inclusive transport. So for example, we've updated the Road Note 21, a sister road note to Road Note 31, which you hear about today, which aims to improve the way we design transportation infrastructure for people with disabilities. We have a number of, as we embark on a further 2 years of the HVT program, just to illustrate a number of the sort of type of work we do, I've highlighted a number of examples of the work that we're doing. we're looking to develop a transport decarbonization index to benchmark progress and really put transport at the forefront of the new set of NDCs. We're supporting the Highway Development and Maintenance Standards Model, HDM4. HDM4 is de facto the international standard for the economic appraisal of road transport investment. It's used by most multilateral development agencies and many governments across the globe, with an estimated annual spend of over $10 billion. So we're collaborating with the World Bank, the Asian Development Bank, and the World Road Association to ensure that HDM4 takes account of climate change and the changes we have with vehicle technology, and of course, the type of fuel we use for vehicles. So those are just a few examples. As we look at for example, in the recent COP agreement on damage and reparations, we're looking at access to climate finance. For many in low-income countries, it's not so much what needs to be done, but it's how to do it and find access to finance, understanding how to access the finance and how to prepare the projects that they are then suitable for financing is really important. So we're looking to work on that. And we've been working on electromobility, and we'll look to continue to do so. So today you will hear one of the streams of the work that we do on decision support systems. We have developed along the way quite a number of decision support systems. You will hear two really important decision support systems, which is the RoadNote 31 that we've been working with TRL, Transport Research Laboratory UK, on, and also the toolkit for resilient infrastructure planning and adaptation by the Universities of Southampton and Oxford University. So thank you once more. I welcome you. And I'd like to now hand you over to Mark Harvey to provide a keynote. Mark is the head of profession for infrastructure at the FCDO. Over to you, Mark. Thank you.
Thanks, Bernard. Can people see and hear me online and in the venue? We did test this just now. I think I heard a yes. Was that?
Yes,
it was a distant S. Okay. Well, very grateful and actually honoured to be asked to give a keynote address. I'm not sure I actually have the credentials to do that, but I do remember interacting with Bernard a very long time ago in Botswana, so we go back some way. Not been directly involved in this, but very pleased to be participating. Hope you have a good session this afternoon. I won't bore you with the difficult transport journey I had to get to the FCDO office near Glasgow this morning, which has caused all sorts of problems for me, but we'll move on. I was given some points to make in the keynote address, but I just hearing what Bernard said just now and knowing that you're going to hear from some of the people who've developed these two tools, I'm not sure if I need to go into that level of detail. But I will just say a few things. I'll pick a few things out for some notes that I was given. We know that the efficient movement of people and goods around countries is absolutely essential for growing economies, and essential for even those economies that are not growing perhaps as well as you would like them to. And we saw that in recent years with the pandemic, that when people stop moving and goods stop moving, that economies can quite literally grind to a halt. So the infrastructure needs to be robust and fit for that purpose. And we know also that the most pressing challenge is the climate crisis. Although I'm not a road transport expert in any way. I do remember a long time ago somebody telling me that roads was all about materials and hydrology, and you've got to get the two right and working together effectively. We also know that roads and rail infrastructure is expensive. It's an expensive business. So having the right decision support mechanisms is hugely important. Which is why FCDO, DFID as was, and FCO as was, in their work in infrastructure, considers it's an essential for growth and needs to be resilient to current and future impacts. So we've got to make sure that transport infrastructure is at the heart of greener, sustainable economic growth. So the two tools that you're going to hear about from the University of Southampton and Oxford, and the update of the Overseas Road Note 31 are really important for us today. Going back, the Road Note 31 came from FCDO's predecessor organisations, DFID and before that ODA, that supported funding road research and development for several decades. I'm sure you're all aware of that. Produced several guidance documents, and the Overseas Road Notes were particularly valuable from the 1960s. They cover a wide range of issues: axle load measurements, road design, maintenance, road safety, bridge maintenance. I could go on. And the sister documents of Road Notes 18 and 19 have contributed to many success stories, such as the Kampala Northern Bypass in Uganda. These were updated, and there was a particular important piece of work done. The Road Note 31, which was first produced in 1962, was then updated following a DFID-funded study that looked at, in particular, at the low traffic end of the fourth edition of Road Note 31. And many countries, as Bernard's already said, have based their own road design manuals on that Road Note in fourth edition. But since then, a number of changes and challenges have arisen. Road pavement design has made significant advances in recent years, a new understanding of the performance of roads. The level of traffic in low and middle income countries has risen significantly, which has seen the need to revise the road notes and take account of the maximum standard axle repetitions, which I've never heard of before. There we go. There's a technical term that I need to learn. And the effects of climate change are clearly the most important thing that is affecting road infrastructure. And lastly, it's the decision support systems around making strategic transport networks resilient that is really important. So the work from the University of Southampton and Oxford on the suite of online decision support tools using open data to map and model the impacts is going to be extremely valuable. We know that flooding and other climate hazards are causing direct damage, and this free to access interactive tool that will enable mapping of risks to road and rail infrastructure for things such as flooding are going to contribute to risk reduction and hopefully reduced costs of interventions. So that tool will provide the evidence and guidance to help decision makers prioritize future investments. Very, very quick overview. Sorry to rush through those notes, but I did want to use this opportunity to speak to you all, and I've no idea how many are in that room in Westminster Hall, to give credit to two people that influenced my thinking around this, as well as Bernard and his colleagues. But I'll give credit to Colin Gawley, who recently moved on from DFID and FCDO, but he was the one that certainly convinced me at an early stage a few years ago that we need to use the opportunity to update the road notes with the latest thinking. And I also give strong credit to him. He and I would often compare notes, even though I was less of a transport sector person than he was. We would compare our reference documents that I still had a copy of Road Note 31 in my attic at that time. So he made a compelling case that we needed to support the high volume transport research program, and I can see that it's doing a great job. The other person I would give credit to, which goes back a very, very long way, is Colin Ralph, who I met with the ILO in Southern Africa many, many, many years ago. And the one thing he said to me was, you can have roads without development, but you can't have development without roads. But I think actually now what he means is, or meant was, you can have, you need resilient transport services to have development. And I think that's where we need to focus. So I leave that message with you, that it's the transport services that we get from all this infrastructure that's absolutely vital for economies and people and our own well-being. On that note, I will pass back to Bernard and wish you well for the rest of your sessions. I'm going to be listening in, so thank you. If that's time to move back, I have no idea how many are in the room. It would be great to know who I was talking to, but I know you've got a fantastic audience from many, many countries from around the world. So congratulations on all that you've been doing so far.
Well, many thanks, Mark. And now, and somewhat following on from what you've just been saying, I'm now delighted to introduce two speakers to share an overview of the update to Road Note 31, a guide to the structural design of surface roads in tropical and subtropical regions. This critical guide was, according to my notes, last updated over 20 years ago, in which time so much has changed, including, of course, the intense pressure from climate change. Therefore, I'm extremely pleased to welcome Dr. John Rolt, who was the lead author of the Road Note 31 in its previous 4th edition, and now involved in the 5th edition and bringing more than 40 years experience in road engineering. John will then be followed by Andrew Otto, who is team leader on the project to update Road Note 31 and brings more than 15 years experience of material and pavement engineering. John, the floor is yours. Okay. And that is the clicker, yeah.
Okay. Okay, good afternoon, ladies and gentlemen. I hope you're ready for this. The new edition of Road Note 31. Who was that? It's about 200 pages long, and I've got 15 minutes to present it. So are you ready? Let's see. First slide. Ooh. Oh, sorry. I'm not obviously going to go through 200 pages. I'm going to do two things. I'm going to introduce essentially the advances that we have made in the last 25 years. And I'm also going to introduce my colleague, Andrew, who's going to go into slightly more detail about one or two selected topics, obviously not 200 pages worth. Right, whoops, I keep pressing the wrong button, don't I? We've already mentioned this. The 4th edition was launched in 1993 and was and still is popular. And the important issue here is that it's actually based on empirical evidence from research in tropical countries. And I mention this because if you know anything about highway engineering at all, you'll know that there's a lot of things that have been said that are wrong. There are manuals with wrong information in. You have to be really quite picky to get the right one. So it's very important that we actually have empirical evidence to prove what we're doing. And that was the key to our particular studies. It filled a gap where country manuals did not exist. There were many countries that didn't have their own manuals at all in those days. It is concise and easy to use. I have to say that, don't I? Because I wrote it. It's very concise and easy to use for me. If anyone doesn't agree with me, I can change it. And it generally met most of the needs at that time. Whoops, I keep pressing the wrong button. Just for those of you who might be a little bit confused, it's actually changed its name 3 times. Not that that's a particularly important issue, but it's worth mentioning at least once. The word regions has gone into the 5th edition because there are places that are not countries that require obviously roads. So it said tropical countries in the first one, and then it's changed to regions. Very small point, but right, this is an important slide. What it's trying to show is that the length of the document has grown exponentially from 1962 to 2000, where we are now. If you plot that on a graph to show that it's an exponential increase, you will see that if there is another edition, it will not be in 1 volume, it will probably be in 3. But what it really shows, and this is the particular point I'm making, is that between the last edition and the new one, there's been a really lot of new research and new results that are actually quite amazing. We're talking about 25 to 30 years of advances, and those advances have been very, very significant. Right, when a design manual is updated, most of the changes are usually quite small and incremental improvements. But occasionally, a major change occurs that is often called a paradigm shift. At least scientists call it that. The paradigm shift that you're probably all familiar with is when Copernicus discovered that the Earth was not the center of the universe, but actually rotated around the sun. Now, I'm not suggesting that any of our discoveries are quite as important as that, but nevertheless, there are some paradigm shifts, big changes that have occurred in the last 25 years. Right. One of the most significant is this one. Studies that we did in TRL way back in the late 70s and early 80s indicated that roads were not failing in the way that everybody assumed. In most studies or most manuals, they assume that the asphalt surface at the top of the road cracks from the bottom upwards because it's being bent by the traffic. If you bend something like that, it cracks from the bottom. In Kenya, we did not find any roads that cracked in that way. They were all like this. This doesn't prove that the cracks start at the top. If they stop in the middle and you're taking the core in the right place, you can be fairly certain that the cracks started at the top. Now, the other point is that these cracks only go down so far, and in order to repair that road, the cheapest thing to do is to mill off the top part that's got the crack in and replace it. Now, if the cracks all go right through, you have to replace the whole of the surface. Maybe 4 to 6 inches of asphalt has to be replaced. But by milling off the top, you can put a new top surface of 25 millimeters, much cheaper. This has saved millions of pounds and dollars even, or yen even, whatever. I can't even put a figure on it, it's just so large. Right, whoops. Oh. So it would help if I didn't. Now, going back to that slide, it wasn't just TRL that discovered this. In 1982, 1986, other people had noticed the same thing. There were 4 or 5 papers in 1982 where people had observed the same thing. But the one that really stands out for me is a paper by 2 French engineers who had done a survey of roads in France. And they had concluded that 86% of the cracks in their asphalt roads were from the top going downwards. And that is a minimum figure because if a crack goes right through, it's very difficult to determine where it started. So the 86% was a basic minimum. And that was a mind-blowing number. I mean, we'd found 100% on the roads we were looking at in Kenya. And at the time, I wrote to one of the world's leading pavement designers, a professor at California Institute of Technology, who's now just retired. And he was a very genuine guy. A lot of people didn't believe this. This took a long time. It's a paradigm shift. Paradigm shifts take a generation to be accepted, generally speaking. I wrote to him and he wrote back a very nice letter I kept. It said, yes, he did recognize that cracking sometimes came from the top, but it wasn't very common. I didn't like to tell him that 86% of the cracks in France were this way, but it's taken about 25 years for this particular point to be really accepted worldwide. That's the kind of inertia, if you like, in the system. Right, some of the other major changes, I'm not going to go through them all in detail like I have that one, but the second one is quite important. Failure at subgrade level is rare. Recent research has established a revised knowledge of the traffic carrying capacity of the subgrades. Now, for years and years, the famous American study in 1960 generated an equation for the life, if you like, of subgrades. And that equation and the graph that goes with it has been used all this time. And we never really quite believed it. We always thought that subgrades were carrying more traffic than that. And 10, 15 years ago, a significant study was carried out in the US Army's accelerated pavement facility in southern New York State by some very, very competent engineers that showed quite conclusively that the subgrades were actually a lot stronger than we had assumed for 30 years. And the proof of the pudding really is that subgrade failures, unless you've got a real serious drainage problem or something, subgrade failures are actually much rarer than people thought. The third one is fairly new. Obviously, when you have pavements carrying a lot of traffic, it takes a long time for them to reach failure. And so there wasn't a lot of evidence, but there is evidence now that if you design a pavement to carry 80 million standard axles, that's typically maybe 20 years worth of traffic. There is no benefit obtained by increasing the pavement thickness to carry more traffic. These pavements we're labeling LLP for long life pavements. All you need to do is replace the surfacing or part of the surfacing because of the top-down cracking, and you don't need to keep increasing the thicknesses. All the design charts prior to this, you just extrapolated the thickness. If you wanted 100 million standard axles, it was 300 millimeters thicker than the one below it, etc. That is actually a complete waste of time. You don't need to do it. So that is, again, a bit of a paradigm shift. The other point 4 is perhaps a little bit more obvious to most people. If you use a system that involves designing quite strong foundations, it actually saves you for building the upper pavement layers. They don't have to be so thick and so on, and therefore the overall costs decrease, but it also produces longer life pavements. So that's perhaps not so surprising. And then, of course, 5 and 6. 5, Andrew will say a little bit more about knowledge of climate change and methods of minimizing its adverse effects have advanced considerably as the need has arisen. So as we all know, there's been quite a lot of research in that area. How it applies to roads and highways is what we're on about for Road Length 31. And all those things have been included. And also improvements in methods and materials for road building has also advanced quite significantly. So the last 25, 30 years have really been, I use the word dramatic. That's a dramatic word to use, but it's been literally a paradigm shift. So many things have improved in that time. And I think Andrew is going to go into slightly more detail. I think that's the end of my Oh, Andrew, yes. How do we get Andrew?
Yeah, thank you very much, John. Let me carry on from there. Can you advance the slide for me to the next, please? Yeah, I'm going to highlight some of the current and future challenges and then give an overview of how the RN 31 5th edition addresses these challenges. The first obvious one is the effects of climate change. As you can see from these photos here, they affect coastal roads and then also inland roads by deformation of the surfaces, either from temperature or rainfall, destruction of bridges and road embankments and various infrastructure. Next slide, please. The next major challenge is environmental degradation, and the road sector, the transport sector has a major contribution to this through direct emissions into the atmosphere and particulates from tire degradation and various other things. And most of these contaminants end up in streams and rivers, which are often used as potable water sources. And the next challenge as well is recycling of materials, either from other sectors or produced by roadworks themselves. Next, please. A major challenge and a major change is in traffic characteristics, particular track characteristics. Previously, trucks used to have 4 tires on the load carrying axles. And now we're seeing an increase in the use of super singles, which means 2 tires per load carrying axle. Obviously, this is going to have different load effects and damage effects on road pavements, and the effects, the use of these tires are increasing. So that is a major current and future challenge. Next slide, please. So the Road Note 31 5th edition has reacted to these challenges, as well as to the growth in knowledge that John explained earlier. And we have included guidance on the design of concrete pavements to help with climate resilience and increased axle loads. Pavement rehabilitation, because the damages from these challenges are going to increase on existing roads, and the use of climate resilient surfacings and pavement drainage enhancement, as well as enhancement in chapters of traffic and subgrades and materials. Next slide, please. So in terms of temperature effects and heavy traffic loading on pavements, many of you will have seen these kinds of appearances on your roads, shown in the photos here. And in the RN 31 5th edition, we have put more emphasis than it was in the 4th edition on designing for rut resistance using simple but cost-effective methods. Next slide, please. There's also guidance on the use of epoxy modified asphalt surfacings and chip seals, which are known to be resistant to extreme temperatures, resistant to asphalt or bitumen oxidation, and they offer increased life and lack of susceptibility to moisture permeation. And this we have linked also, we've provided also a link to Road Note 42. And Road Note 42 is a best practice guide for durability of asphalt pavements. Next slide, please. As regards effects of rainfall, there is changes on subsurface drainage conditions in pavements that are caused by the general gradual increase in overall rainfall as a result of climate change. So there are options and guidance offered in the RN31 on how to deal with this in road pavements. And they include the use of filter materials and geotextiles. Next slide, please. There's also the other effect of climate change, which comes from extreme storm events. And this causes washouts of roads and embankments and various infrastructure. So we have included guidance on options of how to address the challenges that come from extreme storm events. Next slide, please. So how will the RN31 be used? The RN31 still remains a guide, so it can be and should be used with other manuals and guides, but can also be used independently. It can also be used for comparisons of designs and as a benchmark with other manuals. And the key part, the key feature of this RN31 is its flexibility, which you will notice when you start using it. The next slide, please. It's also, as John mentioned, based on empirical evidence collected from various studies, and these have been verified, extended and verified using calibrated mechanistic empirical approach. The next slide, please. So the RN31 is being hosted on a website, and this system allows for users to give feedback, and this feedback will be gathered and used for revision of the next, for future revisions of further editions that are to come. And the next slide, which should be the last. Okay, we would like to thank the entire team consisting of the project advisory group, reviewers, stakeholders who contributed via comments, road agencies, other contributors, the PMU and HVT PMU, and support of the FCDO. Thank you. And at this moment, I would like to invite one of our key stakeholders to give a few remarks on the RN31, and that is Engineer Elias Paulo, who is the Director General of the Mozambique Road Administration, known as ANE. And the ANE is in charge of trunk, national and secondary roads in Mozambique, which also consists of paved and unpaved road types. Please, if the team could allow Elias to give a few remarks. Thank you.
Andrew, I don't think Elias has been able to join the call as he's not connected. So perhaps you'd like to introduce your second speaker and we'll see if we can connect.
Okay, that is fine. The next speaker, I hope is connected, is Dr. Nazmus Saqib from Bangladesh. He's an assistant professor at Islamic University of Technology, Dhaka. He conducts research on bitumen chemistry, asphalt moisture sensitivity, sustainable pavement materials, including polymer modified bitumen. Professionally, he has been involved in preparation and review of specifications related to climate resilient roads, and introduction and application of the latest technical know-how in the Bangladesh pavement subsector. Please, Dr. Saqib, if you're on, please give a few remarks.
Thank you, Mr. Otto, and thanks for inviting me in this prestigious occasion. It's been an honor to be here. So I first of all, I want to thank UK8, HVT, DT Global, and TRL, of course, for preparing this report. And I believe you guys put a lot of hard work, and it can be seen in the finished product. So actually, RN31, the 5th edition, has been really an opportune arrival for Bangladesh pavement industry. The reason is we have been using RN31's 4th version, which is the older one, for quite a while, and we have adopted similar codes for our roads, especially low-cost roads. But the thing is, Bangladesh has been going through a huge economic and social evolution in last decade, I would say. So traffic and people's mobility has been increasing drastically. So for this reason, I'm very eager to see how this pavement and how this traffic, that's one of the key additions to RM31 with the 80, I believe it's 80 million SL, so which is going to be very useful for our context. So that's something I'm really excited about. Second thing I want to talk about is the climate resistant design that you are proposing. So of course, you guys know that Bangladesh has been in the forefront of any list of climate affected countries. So we are seeing longer and heavier rainy seasons. We are also seeing colder winters and also prolonged summer. So everything that's not good for pavements is happening around here. So I believe RM31 addresses one of the major concerns. Second is we want to use this very quickly because there are a lot of projects going on and a lot of research is going on for this climate resistant roads. I think that this code will be readily accepted and will be applied. And of course, we'll evaluate the performance for the marginal cases because we are at the borderline of what the designs propose due to the traffic as well as climate. So hopefully, as you advised, we'll provide the feedback to you guys. Third is we import a lot of materials from abroad. Bangladesh doesn't have a stone quarry and also a bitumen refinery. No, so we always import this material. So having a larger material inventory in the code is going to be really useful for our case because the quality control is something that we are eager, but we don't have much control of it. So we have to adjust our design according to the material that we are provided. I have also seen the epoxy modified binders. I am personally not really familiar, but I'm excited to use it because something that makes sense, makes perfect sense to be used. Finally, to keep it short, I want to congratulate you guys on keeping it as a guide because there's a tendency as an academic, there's a tendency to over parameterize, over complicate this kind of report. So thank you for keeping it as a guide that's oriented to our curious engineers, not entirely for academics, but we will get in touch, of course. Finally, I'm really excited about seeing you guys in Bangladesh. I believe you guys are coming to introduce this RM31 to Bangladeshi engineers. So I hope I will join there and see you there. Thank you.
Okay, thank you very much. Lastly, from my side, I've got testimonials by one of the key stakeholders from Lao. He may be on the call here. Is Engineer Richard Humphrey, who is a team leader and a resident engineer for the Rural Development Program in Laos since 2009. And I'll read this verbatim. It says, the Rural Development Program in Laos, PDR, funded by KfW, the German Development Bank, has been constructing rural roads in poor districts in Laos for the last 20 years. The objective of the program is to improve the socioeconomic status of villages by providing access to market, education, and health facilities. Since 2013, the program has been using the TRL ORN31 as its design guide. And this has been a valuable tool for ensuring the adequacy of design. Since 2018, the Ministry of Public Works and Transport of Laos has incorporated ORN31 in its road design manual. We note that the updated 2022 road note now expands on the design of rural roads, catering for increased axle loadings in Chart F, which will be of particular use given the generally increasing vehicle weights in the country and also provides increased guidance for climate change adaptation measures, which is also useful given the perceived increase in rainfall. We'd like to take this opportunity to thank TRL and its associates for the efforts put in updating Road Note 31. And that was from Engineer Richard Humphrey of Lao Rural Development Program. Thank you very much for that feedback. And I think maybe our team from Mozambique has joined to give a few remarks. Engineer Elias Paulo, the Director General of ANE, I think is online now. Please take 5 minutes to give a few remarks. I had earlier introduced you as being the Director General of Mozambique Road Administration. Thank you.
Thank you. In fact, I'm the Director General of the National Road Administration in Mozambique. We have been involved with the colleagues from the HFT team on the revision of the Road North 31. And it was for us a pleasure to be involved in this very, very important the work. And also it gave us an opportunity to participate in collecting the necessary information to be used part of the updating the roadmap number 31. We, as National Road Administration, which is the road agency in Mozambique, participated actively by collecting historical data, payment performance data, and also conducted the field and the laboratory testing. I think that these data, they were also very important on the revision of the 5th edition of roadmap number 31. Just to say that we had a very collaborative engagement with all stakeholders involved in this process. It was an opportunity for our staff to interact and share the knowledge with experts involved in this process. We had a dissemination workshop organized by HVT in December 2022. Also gave an opportunity to Mozambican stakeholders involved in the road design and construction, namely the universities, the contractors, consultants, municipalities, and of course ourselves, to interact with authors of this 5th edition and explain an explanation of many aspects, including in the new edition. Just to say that Roadmap 31 is one of our main documents being used in Mozambique, not only for the road construction, but also in the universities for training of the engineers. Just to say that I'm one of the engineers who is using this document since my university time, and I consider it as a very useful tool for the road design and the construction. We have recently updated our pavement design manual, which was based on Roadmap 31, or 4th edition. We are therefore pleased that there is this now 5th edition that supplements information contained in the Mozambican pavement design manual. As I mentioned, we recently participated in the dissemination workshop of the 5th edition Mozambique. We were pleased to note that the information that supplements our manual has been included. This includes evaluation of axle loads to consider the effect of super single tires, climate resilience, which is our, as you know, we are almost every year, we suffer from the climate resilience, cyclones, it's our roads, and the design of concrete pavements. We were happy to use this road, the 5th edition, to provide a several pavement catalog, which an option to choose from depending on the situation. We believe that, excuse me, as we continue to use the Roadmap 31 together with our manual, we shall find many challenges or advantages. For this reason, and as you know that we are Portuguese-speaking country, we would like to request the translation of this document for the Portuguese language in order that our lecturers at universities, colleges, and the contractors, consultants, and the other engineers who are not so fluent in English to be able to use them. And to finalize, I'd like to thank the HBT and all staff involved in updating this Road Note 31 and remind them that this is a live document and request the availability for any request for clarification that may arise from its use. Thank you so much for this time, and also thank you so much for Mozambique for being part of the team who is working on this, the revision of this 5th edition of Road Note 31. Thank you.
Okay, thank you very much, Engineer Elias Paolo. We were very, very grateful for the support given by Annie. Can we now hand back to Professor John Preston? Thank you.
Thank you very much, Andrew, and thank you, the Road Note 31 team. So I'm asked to just look at some clarifying questions. Most of the clarifying questions, I think, have been about the availability of the slides for this afternoon, of the recording for this afternoon, and of Road Note 31, and I think they've been answered by the DT Global team. I don't see any other clarifying questions in the Q&A section on Zoom. Are there any clarifying questions in the room for John or Andrew? Do I feel I should exert Chair's prerogative and ask a clarifying question? There's one here by Raghav. Sorry, Raghav, hidden behind Adrian.
Yeah, hiding behind the pillar. Thank you very much. I'm Raghavan from the University of Oxford. I just had a kind of curiosity question about Road Note 31. I have to admit I haven't seen it. It's like, can we use Road Note 31 to estimate how much would it cost to build climate resilient roads? How much extra it costs over what would be an existing design of a road? Does Road Note 31 help us to do that? Thank you.
John, would you like to answer that? I think a microphone's coming in your general direction right now.
The answer is yes. Obviously, climate resilience and climate protection is a key part of the new Road Note. And I hope you won't be disappointed by it when you see it all.
Thank you. One question has now appeared online, and it's, does the 5th edition consider human activity? Obviously, the problem is online. I don't quite know what the questioner means by human activity, but John, could you respond to that?
I'm sorry, I don't understand what it means either.
Well, Rex, there's a follow-up question from somebody different, which does RN31 also address climate resiliency of the complete pavement structures or only the surface?
Oh, the complete structure, yes.
Yeah, I would have expected that to be the answer. There's another question about downloading the link for RN31, as you appreciate. Okay, well, the first question hasn't followed up about what they mean about human activity. I am not going to use chair's privilege because we're already running slightly over. The organizer looking appreciative there. So introduce the second project on decision support tools for long distance transport, and that's going to be a triple header, at least eventually, Simon, Tom and Deanna, but perhaps I introduce Simon first of all. Simon, the floor is yours.
Thank you very much, John. Okay, well, thank you, John. Hopefully the slides will appear in a moment. Yes, so my name's Simon Blaney. I am the project lead for HVT project 043, Decision Support Systems for Resilient Strategic Transport Networks. And the project has been undertaken by quite a large team. There are 6 of us here today who you can see pictured. You'll be hearing from some of us as well as me later on, but there are also several people who can't be here today, and it's important to acknowledge their hard work, which has gone into bringing this project now almost to completion. So I thought it'd be helpful by starting to just give a little bit of background to the project before I move on to the key outputs. Now, as I'm sure you're all aware, transport networks are key lifelines that provide mobility and access to sustain the delivery of essential commodities and of people around the world. And access to resilient and sustainable transport networks is clearly key to achieving many of the UN's Sustainable Development Goals. However, it is also widely recognised that there is a very large transport infrastructure deficit in many parts of the world, and perhaps particularly in the African continent, which has been the focus for this project. And in order to deal with this deficit, there is quite an urgent need to make progress in infrastructure development. Now, there is some movement here because, to start with, in many countries in Africa, including the 4 countries we focused on in this project, so Kenya, Tanzania, Uganda, and Zambia, there is the prospect of strong economic growth and of these countries becoming increasingly important gateways to the growing domestic markets in Africa. And because of this and linked to this, there has been significant large-scale infrastructure investment in these regions in recent years. However, while this investment is taking place, there is a very real danger that natural hazards, particularly those resulting from and exacerbated by climate change, could prove detrimental to these growth and development plans and put at risk some of the investment that has been made in infrastructure. And alongside this risk to resilience from natural hazards, there are also some broader sustainability concerns that investment has perhaps been focused too heavily on economic growth, and particularly on enabling road traffic at the expense of other sustainability considerations. So the ambition of this project was to provide transport decision makers in lower income countries with a set of support tools which would enable them in their decision making to prioritize transport interventions that will deliver truly sustainable and truly resilient long distance transport networks in the long term. That was what we were aiming towards, and that's what we've been trying to address over the last 2.5 years, working with stakeholder partners in our 4 case study countries. Now, it's also important to mention at this point that clearly in all the countries we're looking at, there are existing tools for helping decision makers to prioritize interventions in infrastructure, some of which will be more sophisticated in certain respects than anything we could hope to develop in this project. So in everything we've done, we've been trying as hard as we can to develop tools which can complement rather than replace the existing things that are there, and developing things which allow perhaps the outputs from existing tools to feed into this broader sustainability assessment. So there were 5 broad research questions that we were aiming to address in the project. First of all, looking at the expected range of future exogenous scenarios for transport in the region. Secondly, looking at actually what data you need to develop an effective decision support system for long distance transport in this kind of context. Then building on those first 2 questions, looking at how resilient long distance transport infrastructure in the region is to climate related and other hazards, and how perhaps can infrastructure be adapted to improve this resilience. Alongside that, looking more broadly at how the sustainability of the long distance transport networks in this region can be quantified and assessed. And then finally, looking at ways in which stakeholders can be assisted to assess the relative performance of different transport intervention and investment options against a range of sustainability metrics. So we've been addressing these research questions through a set of 5 interlinked work packages, plus a 6th work package around management, engagement and dissemination. That stakeholder engagement and dissemination has been key throughout the project, and we have held a number of both online and in-person workshops as the project has progressed, which some of you may have been involved in. But what I really want to focus on today is the key outputs that have arisen from these work packages and where perhaps this could go next. So the first couple of things we did, and I won't go into too much detail here, were firstly to develop a set of future scenarios for some of the key drivers and influencers of transport demand. So this is particularly population growth, economic factors such as GDP and energy costs, and climate change, because these scenarios do form the basis for any sustainability assessment of specific interventions that you might make. So we developed a set of future scenarios, and there is a report which sets those out. Alongside this, we undertook a fairly extensive data availability assessment and then a data collection exercise, looking to get as much information as we could about the existing long distance transport infrastructure and usage within the case study region. And this was focusing particularly on open source data, because that was quite an important consideration for this project, that we needed to be able to freely share all the things that we were developing. So these two kind of enabling steps then fed into the real meat of the research here, which is firstly the risk and adaptation analysis, and secondly the sustainability assessment. And I'll go into these in a little bit more detail, bearing in mind we have only got a limited amount of time. So firstly, looking at the risk and adaptation analysis, there are a number of steps which this analysis went through and which are actually quite transferable to other contexts as well. So we were focusing particularly with this case study implementation on floods. And the first thing we needed to do was to assemble flood hazard return period maps for various flood severities across different climate scenarios and futures. And here we used river and coastal flood maps from global hydrological models and using global climate scenarios from global climate models. So reasonably standard and freely available data. What we then did alongside this was to assemble data on multimodal transport networks within the region. And we based this again as much as we could on open source data. So we used primarily OpenStreetMap data to form the basis of connected road and railway networks for the case study region. Now, infrastructure is one thing. It's a bit harder, as I'm sure you'll appreciate, getting information on the actual usage of this infrastructure. And this is where a bit more ingenuity has been required. So what the team did was to build estimates of trade, import and export flows between countries using open global data sets, and then use high-level statistics from specific border crossing points to assign these international flows to specific locations within the countries. And based on this, we could then estimate modal split and then assign these flows from the borders to the countries onto our domestic networks to give an estimation of network usage, which we could then use later to assess potential losses from flood risk events. So that's step B. Step C then is to look at the actual exposure of our infrastructure to hazards. So what we did here was to overlay our infrastructure with our hazard map, and then from this estimate flood depths and lengths for each of the assets that might potentially be inundated. And what we could then do is produce graphs like this, which show the total estimated length of infrastructure that would be exposed to a particular kind of flood event under different future climate scenarios. And we did this across a number of different possible futures. Once we've done this, we can then start to look at actually assigning a cost to these risk events. And again, there's a few stages here. So two kinds of costs were estimated. The first of these are the direct damage costs, which we estimated using damage curves. So this is looking at the percentage or fraction of damage that will be sustained by a given asset for a given flood depth. And you can then combine this with data on rehabilitation costs to look at the financial cost in direct terms of a given flood event. And you can see an example of that kind of calculation here. Clearly though, the direct damage to the infrastructure isn't the only cost that we're going to incur. And we also need to look at indirect economic losses, which would be incurred as a result of trade disruption. So what we did here was to take our data from step B, looking at where we think flows are going at the moment, look at which flows would be disrupted in the event of a given flood event, and then look at which flows might be rerouted or which might be lost, and then assign delay and loss values as a result of this disruption. And based on that, you then get an estimate of how much this flood is actually costing you. And then finally, steps D and E then feed into the calculation of metrics of risk, two estimated in this study linked to those two previous steps. The first being the expected annual damage. So this is based on that direct damage to infrastructure. What this is saying is basically if you spread out equally all the damage from all hazard probabilities and magnitudes over time, the expense that you would get in any given year is your expected annual damage. And this map is showing an example of how that varies across the different links on our network to railways in the case study region. I thought I was going to have another slide there, apologies. Alongside that, then we've got the expected annual economic losses. So this is similar, but this is looking at evening out that loss due to trade disruption that you're getting as a result of the flood event. So you can look at this across your network and get an idea of which the most critical links actually are. But of course, it's not just about what's getting broken. We also need to think about how we can actually adapt our network to resist these events. And what we've done here is to look at 6 different possible adaptation options and to calculate basically a cost-benefit analysis of applying each of these options for each of the links in our network. So this then allows us to identify for a given link what the most appropriate intervention might be and where on our network interventions to improve resilience would give maximum value. And we can construct graphs across our network looking a bit like this, which allow us to identify which road assets would give the maximum return, or railway assets, if you were looking at railways, for a given kind of resilience intervention, and which interventions are likely to deliver the maximum value. And I won't go into any more detail because of time, but this is all set out in a lot more detail for our case study region within the reporting. So just to summarize for the resilience analysis, what you're getting is basically a set of output metrics which allow you to understand a number of aspects of your network in terms of how resilient it is and what you might do to make it more resilient going forward. But of course, resilience is just one of the factors that we need to consider when prioritizing interventions from transport systems. And this is where the second substantive part of the analysis comes in, where we look at assessing interventions in terms of their broader sustainability. So there's kind of 2 parts to this. The first thing we did was to develop a comprehensive range of indicators which can help inform future decisions affecting long distance transport. So this is split into the 3 main aspects of sustainability. So environmental, economic and social sustainability. We've got a number of different indicators within each of those themes. These are things that you would need to consider for any given intervention option. And these form the basis for the option assessment tool that we have developed. So a few key principles which underpin this tool. Well, first of all, what we're trying to do here is we're trying to assist decision makers in assessing the overall sustainability of transport intervention options. We're not making the decision for them. We're giving them information which allows them to compare the performance of different options, but ultimately it's up to them which one they take forward. So what we've used here, because of variability, let's say, in the data availability for some of these indicators, is we've adopted a multi-criteria analysis-based approach. But there is the option to use quantitative outputs from locally used modeling tools to input into this process. So what we've tried to use is a fairly hybrid approach. So where there's a number, you can use it. Where there's not, you can apply a rating. But you are able to use the best information you have available to feed into this assessment. So what the tool will give you is a high-level indication of how a given intervention is likely to perform with regard to different aspects of sustainability. And it's up to then the decision makers to decide which of those aspects has the greatest importance in their particular context. So in actually carrying out an option assessment, there's 3 stages you go through. This will probably become a little clearer when Tom shows you the tool itself in a moment. But first of all, the user has to select the intervention and scenario options they want to consider in their assessment. They then have to agree the expected impacts of this intervention for each of the sustainability indicators, either confirming the default outcomes in the tool or providing alternative outcomes based on their local knowledge and expertise. And we would normally recommend that several people go through this process independently to try and reduce the decision maker bias that might be expected if only one person is doing this. And what the tool will then do is it will present the results from this assessment via a dashboard, which gives you the expected impacts on sustainability for each of those three main pillars of sustainable long distance transport. So before I hand over to Tom, I did mention already that we have engaged with a large number of stakeholders throughout the project. This has been key. Initially, this was through online workshops and surveys, but we did in September last year visit all of our key countries and actually held workshops with stakeholders in each one. And this was really helpful in enabling us to get feedback on what worked well and what needed to be improved. And we met, as you can see, over 50 stakeholders during these visits who were overall very impressed and gave us some really helpful feedback. But I'm running over time already, so I'll now hand over to Tom, who's going to actually give you a snapshot of what the tool looks like and how it works. So the floor is yours.
Thanks, Simon. Let's see how this goes. That's the other way. That's the way I want to go. Okay. My name's Tom. I led the development of the interactive web tool, which presents the results of the risk and resilience analysis that Simon just walked through and gives you the sustainability assessment tool that Simon just mentioned. So the link there is live and sort of freely, publicly, openly available. That's east-africa.infrastructureresilience.org. Encourage you to follow along if you like, or afterwards at home to have a look live. But today I'm going to click through some screenshots of the tool just in the interest of time. This is the homepage, introduces the project and gives a little bit of background. We call it the SRAT, or Sustainability and Resilience Assessment Tool. So the main first section of the tool walks through the risk and resilience analysis. So along the top, we've got exposure, risk, and then adaptation. So we're looking to present the data that we've collected and then the results that we've generated on top of that analysis. So here we've got motorway, trunk and primary roads shown across all 4 case study countries. With roads, we went down to tertiary, so that's quite a fine level of detail. We'll see in the next slide. Key ports and airports as junctions into the wider global transport network. And we've got river and coastal flooding as the 2 environmental hazards that come through. So it's a normal web map. You can zoom around and click on individual links in the transport network. So here, just looking at Dar es Salaam in Tanzania with some of the flood outlines overlaid in the background. Here we're looking at river flooding with a 100-year return period and coastal flooding again with a 100-year return period, both in the present day baseline scenario. So for each of our climate hazard maps, we've got current day probabilities of different types of flooding, different depths of flooding, and future out to 2050 or 2080 under RCP 4.5 or 8.5, which, if you don't speak IPCC, is a medium or extreme climate scenario. So the first step in the analysis is that exposure analysis, where we're looking at roads and the floods that they are exposed to. But if you calculate across all of the probabilities of flooding, you can get these expected annual damages and expected annual economic losses that Simon mentioned. So for any given link in the network, you can click for details, and in this sort of right-hand sidebar, you'll get the change in risk over time under different climate scenarios. So this is reiterating the third step in the resilience analysis, but we can look for each of the road and rail links at the adaptation options that we've assessed, where for any subsector, here we're looking just at primary roads under RCP 4.5. You can pick an adaptation option here, the drainage rehabilitation option that we've assessed. And over on the right, you get the ranked list of all the sort of possible options that you could look at. So this is a first cut prioritization across the whole system. We've ranked them by benefit cost ratio in descending order. You can look at different metrics that we've calculated. And as you click onto any link again, you can look at the sort of full detail of the adaptation options under the uncertainty of those climate scenarios, and with some additional sort of cost estimates and uncertainty bands there too. Okay, appreciate this is fairly rapid, but hopefully we get a bit of an idea of what the tool can do, and that it does present the full open data that has gone into the assessment and the full results that have been calculated through the project. Moving on, so from that resilience analysis, one thing you might come up with is a set of highways that you're interested in adapting to some flood hazard that you've identified that might intensify into the future. And you might have some idea of the adaptation options that would be appropriate for those links. So given that, you can move into the sustainability assessment sort of portion of the tool. It's a slight shift away from the quantitative assessment into considering broader pillars of sustainability. So under this sustainability assessment page, you can create a new assessment and go back to ones that you've saved before. This is entirely within your own browser, so it's not creating something online that other people can view. It's sort of private to your view of the web page. So if you select one, you can create notes and then select the category of intervention that you're interested in. So here, looking at infrastructure maintenance. Underneath that, you can look across those various indicators that we've collected and assign default values to. So a maintenance program would have some positive effect on greenhouse gas emissions due to reduced fuel usage, for example, and so on and so forth throughout the indicators. You've got the opportunity to adjust those default settings and sort of make notes as to what you think might change and why, and work your way through the qualitative assessment process. So once you've gone through that for the interventions, or combination of interventions that you're interested in, the tool calculates through each of the values that you've assigned and gives you that summary across the three pillars of sustainability: environmental, economic and social sustainability, and an overall summary of where you're getting positive or negative effects from the intervention that you've planned. I think that's it. Hopefully that was to time and good. Last mention, so the tool itself is online and open for you to have a look at. The source code behind the tool is on GitHub and linked from the data page, and the data that went into it is also linked and credited and cited there. Feel free to get in touch if you have further questions. Be happy to give you a more casual or relaxed run through it another time. Thank you.
Thanks, Tom. So I'm Diana Jaramillo, and I'm going to be presenting a short little case study application of the work that we did that came from some of the stakeholder workshops that we hosted in Kenya. Unfortunately, none of the stakeholders are able to present, so instead you have the next best thing. Essentially, the case study that we focus on was from the KENHA, the Kenya National Highway Association, and the African Development Bank. They're planning to upgrade and the development of the Leseru Kitale and the Morpus Lokichar sections of the Kenya South Sudan road corridor, and they had reached out to the Global Center of Adaptation because they have identified the need to integrate these adaptation and resilience solutions in order to address some of the current and the future climate risks to the project. So here you'll see a screenshot of the tool that Tom just presented, where we zoom into the area that looks at these two highways. Here we have section 1 highlighted and section 2. I've zoomed in to the areas of these roads that we see will be flooded in the future. This is under the year 2080 with the RCP of 8.5. Of course, you can toggle in the tool to look at different future scenarios. So when we look at exposure, we see that for section 1, around 1.5 kilometers of this planned road will be flooded in the future, not in the baseline. And for section 2, we do see a bit of flooding in the baseline, but we see that in the future, a larger chunk of that road is going to be flooded. And the results from this exposure analysis agree with the environmental and sustainability analysis that KENHA had originally done, but they essentially wanted to see, first of all, if it agreed and also what were the impacts of that. So we calculated the direct damages and the indirect damages and the indirect losses, sorry, by looking at the tool. And here we see some of the results. This is specifically for the second section. I think unfortunately the slides were exported to a PDF, losing the GIFs and the other animations that I had, but it's fine. But here you can see return periods from which basically align with how intense the flood is. So you see that under future scenarios, more direct damages are expected from these roads. And if we translate that to the expected annual damages, and on the left and the expected annual economic losses, we see that first of all, under a baseline scenario, you might not be seeing a lot of costs on an average year, but under future scenarios going from 2030 to 2080, these costs will increase. And under RCP 8.5, you see quite high costs. You can expect annual damages of around 2,500,000, and under worst case scenarios, this can go up quite high. It's also important to know the expected annual economic losses. It's also important to take into account, especially, for example, in the section 1, which is highlighted in green. These can be quite significant, especially compared to the annual direct damages. So these were just some of the results that we found from applying this tool to a specific case study. And then we also took this and applied it with the sustainability indicators to look at what were some of the other impacts aside from the risk and resilience that this project would have. And by toggling some of the weights and some of the impact values and having some more conversations about it, which you can read about more in the report, we found that the proposed interventions are going to have slightly positive effects on all 3 pillars of sustainability. Happy to chat more about it. But for now, I'll just hand it back to John and leave it up for questions. Thank you.
Well, thank you very much, Simon, Tom and Diana, for a very interesting presentation. So the final 10 minutes or so, I'd like to do 2 things. First of all, any clarifying questions about the second presentation, and I've got some online and I'll just chuck in the room, and then open it up to some more general questions or discussion, both online or from within the room. Perhaps I should also say there have been some questions coming in about the first presentation and road note 31, one about recycled asphalt, which I think Andrew's answered online. There's one here about mechanical modification of gravel for base and sub-base layers. I don't know whether Andrew's going to answer that online or whether we could come back to that later on. But what I'll do is I'll go to the questions that are related to the last presentation. Here's a question that is, I think, very relevant, and it's: how long will the data underlying the calculations in the model be relevant for? Will it need to be updated to stay up to date? And is there, which I think we know the answer to that, and is there a plan for this to happen? Which I don't know whether I know the answer to that, but who would like to start on that?
So thanks for that question. I'm Raghavan from the University of Oxford. And first of all, a very relevant question that, of course, this kind of analytics gets updated very soon because data kind of becomes old. One of the things that we have done is like we've used this OpenStreetMap data, and the way we have kind of worked our the back end where Tom showed all the GitHub and everything. It has a process of like you can operationalize the whole process where you can kind of even download like the OpenStreetMap data every day or kind of current data and update your analysis and results. So one of the good things about using OpenStreetMap is that it is being constantly updated, and there are daily kind of updates of that data, which is online. So that helps us, at least from that point of view, to kind of work with the current representation and as best representation of these kind of data sets. But there's also several information on top of that, which goes like, for example, when we estimate damages and losses and adaptation costs and everything. That's why I was actually very interested in the Road Note 31 and if new advances are made in estimating cost of roads, design standards and adaptations of these kind of things, which is also something that needs updating from time to time within the tool. And we are kind of working on, so we have along with this tool that we have created a data specification documentation of all our work. So we might have data that might be old, but then there's a specification in which how that data can be updated if a new user comes in and if they change, they can change those values and rerun our analysis. That's the whole idea of making it all open source and available to everybody so that it can be updated.
Thank you, Raghav. So I think in particular, explain how you might update the infrastructure data. The second question perhaps is getting to the kernel of some other things. How were the uncertainties in future scenarios modelled in predicting the extent of future floods? And I might then put the caveat in, and how might those predictions change over time?
Yeah, I mean, regarding uncertainty, so one of the things when you saw those, I mean, in the interest of time, we didn't go into detail in every graph and every plot and everything, but I mean, if the images are still fresh in your mind, so one of the things you saw in most of these graphs were these large kind of shadings of blue and these colors, right? So those are essentially showing the uncertainty in our results. So we're saying that we don't have an estimate and we can't predict with certainty that in 2050, this will be the damage or this will be the loss. Rather, it's captured through the uncertainty of not just climate hazards, but also kind of uncertainties in cost assumptions we might have taken, damage curves and all these things. And regarding the question about how did we account for uncertainties in all of these things, for many of those, we relied on kind of work that other people have done. For example, in the hazard model and where the flood maps and all of these things come from. They come from work that was done in Netherlands by colleagues in the WRI who have this global flood model. Again, openly available data with climate scenarios derived from global climate models. Of course, there will be caveats of using global climate models to work on specific countries in the world, and there are better versions of that data that might exist. But one of the things we have taken note of all of these, and in our analysis, we have identified that what these uncertainties really are, and we have also done some sort of sensitivity analysis to say that our results are more sensitive in some cases to climate models, or in some cases to assumptions of costs that we might have taken, or in some cases they might be more sensitive to the assumptions of trade modeling that we might have done. So all of that is kind of captured in the analysis. Again, it's a constantly updating process. Thanks.
Okay, thank you, Raghav. Now I've got two more questions online. I'm going to put them together and probably field them to Simon. And the first question, is this tool available to other countries? And if so, does it need calibration to suit local conditions? And the second question is, does the sustainability tools model the effects of increased temperatures in sub-Saharan Africa?
Okay, so in terms of the transferability, all of the methods are transferable. The only thing is we haven't actually assembled the data for other countries, but the method itself would be fairly easily transferable if you were willing to undertake that data collection exercise using the standard data sets we've used. Particularly the sustainability assessment tool would be relatively easily transferable, given that doesn't rely on the spatial data sets in the same way that the resilience assessment does. In terms of the sort of effects of climate change, so that's one of the things really we capture in the scenario section. So we have got different scenarios arising from climate change within the tool. And what we would suggest, for example, on the sustainability side, is you select a particular scenario and then consider, well, in the effect of a substantial increase in temperature, sorry, in the event of a substantial increase in temperature, what would we expect the impact of this particular intervention to be? So you're still going to have to do some work yourself in considering what those impacts would be for things that aren't directly modeled, but we're presenting you with a framework in which you can do that and the underlying scenario data on which you can base your analysis.
Okay, thank you, Simon. I'll now open it up for, oh, sorry, didn't see it at the back there. Yeah.
Good afternoon. Is that on? Yeah, good. Great. It's Anne Jocelyn, and I am from the FCDO. So I want to start by saying thank you very much to everybody who's participated in all of this and the presentations today. I think it's been really, really interesting, enlightening, and highly technical. And it's on that last point that I want to ask a bit of a general question, and that is around the kinds of training and dissemination that are being planned for these tools. Both tools, highly technical, extremely detailed. This is a launch of both of them, and we only have a limited amount of time. And so for the sake of those stakeholders who are participating online from around the world, who might be interested in using these tools, I'm wondering what the plans are to help them know how to use these, how to apply them to their own situations, how to access them, et cetera, et cetera. Thanks.
Tom, I wonder whether you could start answering that with respect to SRAT.
Sure. So there's a user guide that goes along with the website that walks through more than I could cover today, but the kind of initial walkthrough of using the visualization tool. I'd also mention ongoing work that we as a project team are doing with the Climate Compatible Growth Programme, also funded by UK Aid, where there are opportunities for low and middle income countries around the world to express interest in the kind of work that we're doing, and in a demand-driven way we can engage with people from those countries.
Thank you. John, with respect to Road Note 31, how would you answer the question there in terms of ongoing feedback, etc.?
Well, as Andrew said, the thing will be on the internet, and any queries and so on can always be answered. But I think anything like Road Note 31 is essentially an engineering document. It's not, it's part of an engineering, whatever you call it, work. We can't possibly deal with all the engineering issues just for Road Note 31. So we have to rely on the universities and the people that are teaching engineering to use our system as well.
Yeah.
But it, as I say, it will be online. People can use it online, ask questions and get answers.
I think Andrew Otto might want to come in here again online. I know he's been busy typing up answers to questions about Road Note 31 in the online Q&A. But Andrew, would you like to add anything?
Yes, specifically to the question raised by Anne Jocelyn. We've conducted already one dissemination workshop in Mozambique. That was in December of last year. And in February, we are conducting another one in Bangladesh. Now, we have recordings of this, of the Mozambique event, and we shall also have a recording of the Bangladesh event. We also invite participants to join online, virtually, those who are not in the training countries, to join the session live online. And those that cannot join live online have the opportunity to actually watch the recordings and at a future time when they have more time. Yeah, thanks.
Okay, thank you. Bernard?
Yeah, thank you very much. I'd just like to sort of build on that very really important question that Anne asked. Just about, Anne, if you don't mind me, just like to introduce you. Anne is actually the FCDO officer, senior responsible officer for the HVT program, and has been largely part of sort of making sure that it sort of happens. So thank you, Anne. But the question is and I really think it's a very important question. HVT is a projectized program. It comes to an end. The question is, how do we ensure that all the outputs are sustained and trained and there's uptake? And indeed, we've raised the issue of how do we update? Do we have to wait another 30 years before Road Note 31 is updated? And all of those issues need to be answered. But I think another aspect of that is also, we see a number of systems being built. We see, for example, the SRAT, we see Road Note 31, HTM4 is also a decision support system. And another program we're doing is Africa Urban Mobility Observatory, which provides a data portal, which it's the real things that they are all interlinked. And perhaps it's time for us to put in mind how we can connect all of those so that they feed off the other and help to sort of amplify the message and the training and the capacity building. And that's something that I like to think perhaps is something that we could look at going forward.
Yeah, indeed, Bernard. And I think maybe we reflect on Road Note 31 and it being updated after 30 years, but now we have continuous data, open data feeds that maybe make certain activities easier to update than in the past, but there's still that updating process is still not costless. Are there any last questions or comments in the room? Yes, please.
Hi, thanks. Well, my name is Jasper Cook. I want to ask a question about, well, I'm going to return a question. One key problem we have as a consultant engineer and working for World Bank on roads, how can I estimate best the uplift of cost on a road? The Ministry of Roads will say, right, we want this road to be climate resilient. What is that going to cost me as an uplift from a basic standard cost we had before? And as a secondary to that, this only deals with floods, is that correct? And how can it be updated to include other hazards to help me get a total cost uplift? Thank you.
Okay, I think that's going to come back to Raghav. So the first question is how do you estimate costs? And then secondly, how would you extend to other extreme events?
Yeah, it's a bit funny that Jasper is asking this question because I worked with him in Vietnam and he was the one who came up with all the costing of how to upgrade roads to climate to make them climate resilient. So I was like, well, Jasper, it's funny you're asking me the question. But yeah, I mean, yeah, we have looked far and wide, and this is a question. That's why I asked my question about Road Note 31, whether it can be used to find that upgrade in costs in the new kind of work that has been, and I will be very interested. And in this project in Africa, that in the HPT project that we did, and Diana actually did a lot of work on this in looking at kind of different kind of the options that we just presented very quickly. I mean, there was a lot of work that went behind them, looking at kind of a lot of literature review and whatever kind of data that we could find in terms of like different interventions, whether it was introducing drainage or pavement upgrades or swales or those kind of things. And there were some studies which we found which they had done in different kind of countries where they had estimated what would be kind of a certain amount of drainage requirement to upgrade a road to a certain level of flood protection. Again, yeah, we also did stuff in flooding, but we use those kind of things to, I mean, essentially use that as those kind of studies to come up with essentially a process in which, okay, what kind of parameters that you need in, at least in our analysis, in terms of a certain amount of cost required to reduce a certain amount of flood hazard, and then how much that is extra in terms of the cost that you're already at your baseline. So in our study, we have a lot of literature review that was done behind using the numbers that we came up with, but this is a constant challenge. And I think I also don't really have a definite answer. I think there's a need, I think, for a database to be created in terms of that answers this question about what is the current standards to which roads are being designed as well, because a lot of these standards, they give you kind of very detailed and how much materials or how much things should be done, but it doesn't tell you like, is this road, is the baseline also of a road design, to what level of hazard is it designed against? Is it designed for a 1 in 10 flood or a 1 in 100 flood? But those kind of information is missing in most of the literature or even manuals and everything that I find. And that's, for me, that's the kind of a missing gap in trying then estimating how much then it would cost more to increase improve a design standard to say to a 1 in 500 or a 1 in 1,000 flood, or any other hazard for that matter. So yeah, it's an open question.
Okay, thank you, Raghav. Well, the main job of a moderator is to make sure we run to time. We're already probably 9 minutes over, perfectly acceptable these days in the national rail system, but possibly DT Global work to a higher standard. So what I'd like to do is thank you to all the presenters for their presentations, and to all of you for attending this event, both physically and remotely. And the hybrid presentation has worked pretty well. Before we end, I'd like to remind you a recording of the session today will be available on the HVT website. I think there was also a request for the presentation to be separate for those who have bandwidth problems downloading the recording. And an email will be attended with emails will go to attendees with the link. And there will also be more detail about how to access the research discussed today, RoadNote 31, the SRAP tool, etc. DT Global will email those attending with an opportunity to provide feedback, and then we'll post the link to feedback in the chat. I can see it's just appeared. Please take for those of you online, please take a few minutes to give us your thoughts. For those of you here in the room, I'd like you all invite you all to stay for some tea and coffee in the room at the back and some further discussion. That's one of the reasons I don't feel too bad of cutting the discussion off in the room, because that can continue in the antechamber behind us. So once again, thank you to all concerned. Let's give both a physical clap and a virtual clap for those online. And proceedings are now complete. Thank you.